How to validate if a binary tree is a binary search tree. Here I create a new binary tree, and then I insert some values into the binary tree. And here I call the method to check if the binary tree is a valid binary search tree. I pass in the root of the binary tree. Here's the method isValidBinarySearchTree, taking in the root. If the root node is null, then we have an empty tree and we return true. This is a valid binary search tree. Otherwise, we call the method isBinarySearchTree, passing the root and two nulls. The nulls will be used for the min left value and the maximum right value. This is needed to accommodate integer max and integer min. So here's the method isBinarySearchTree. First, we initialize the left side of the tree and the right side of the tree to true. If our left node is null and our right node is null, we know that we've found a leaf node and we must return true. If we have a left node or a right node, we can now check each node. So if our left node is not null, then we must check if it is a valid node. The left node is a valid node if it is less than the current node's data and it is greater than the minimum left value, or the minimum left value is equal to null, which would be the case on our first run through of this function. And yet again, we use null to account for max or min of the integer value. Otherwise, if we inserted the max integer value or the minimum integer value, we would not be able to compare against these values, so we could not have these values in our tree, and our function would not work. Please note, the min left value is set by the last right node's transition. For example, when we transition from 75 to 90, the left node of 90, which is 86, cannot be less than 75. So if we are in range for our left node, then we pass in our left node as the new node for the function. We pass in the minimum left value that we currently have, and we set the max right value to the current node's data. Otherwise, if we were not in range, we can return false. This is not a binary search tree. We then check if the right node is null. If the right node is not null, we must also check if it is in range. So the right node must be greater than the current node's data, and the right node must be less than the maximum right value set by the last transition of the left node. For example, when we transition from 57 to the left node 32, 44 must be greater than 32, but 44 cannot be greater than 57, which is the max right value. If we are in range, we take the right node of the current node, and that will be our new current node. The node's data will be the minimum left value, and the maximum right value stays the same. Otherwise, if we're not in range, we simply return false. This is not a binary search tree. So after we have recursively went through this method and we went down the entire tree, we simply can check if the left tree and the right tree are both binary search trees, and if they are both binary search trees, we can return true. Otherwise, if one returned false somewhere down the tree, then it is not a binary search tree. We return false. And just as expected, this is a binary search tree, and we return true. If you found this video helpful, please give it a like and a comment below. If you'd like to see more videos like this, please subscribe to the channel. Thank you for watching.